Okay, ladies and gentlemen, this is 2.6 equation for a circle. We have worked inside... No, have we worked inside circles at all?
No.
Not really. Okay, so here's what's happening. At the end of this unit, there's all of a sudden a lesson on circles and equations of circles. And then at the end of the next unit, there's also a couple seemingly random lessons about circles. But there is a connection. The connection is that we've been working with the distance formula, or the length formula. We've been working with right angle triangles and a squared plus b squared equals c squared, Pythagorean theorem. And actually that comes into play for the equation of a circle as well. You'll see a lot of familiarities between those two equations. In order to get an equation, it will allow you to draw a circle around the origin, at least for today. We start with an investigation. Then I'm going to do a little bit of a basic why this works type of lesson. And then we have a couple of examples to work through. Okay? So here we go. Portable two-way radios, walkie-talkies, are used by farmers, schools, community watch groups. They can only be used to communicate with another person when the radios are within a certain distance of each other. This is called their range. Alright, here we have an investigation. Near his home, Trevor's two-way radios have a range of about 5 kilometers. Use a compass, draw a circle to represent the range of Trevor's radios. The origin represents Trevor's position. So wherever Trevor goes, he's at 0, 0. Alright, so there's T. And you need to draw a circle that represents his range. If he is standing here, where could you be standing and still get walkie-talkie reception? And you're going to draw that circle with your compass. Well, let's look along our x-axis, like due east from where Trevor is. How far along there can I stand and still get service?
5.
I can stand 5 kilometers away. What if I were to the west of Trevor?
5.
Down there at -5. What if I were at the south of Trevor?
-5.
-5. What about the north?
5.
5. Are those the only 4 places I can stand?
No.
No, the range becomes a circle. Okay, so go ahead and draw yourself a circle. Mine is not going to be perfect because I don't have a compass.
That's a nice circle. Pretty perfect though.
Not bad. All right. Label the x and y intercepts of your circle. Label the x and y intercepts of your circle. So we're going to say this point along the x-axis is what? What are the coordinates of this point?
0, 5. No, yeah, 0.
Coordinates are always x, y.
0, 5.
Coordinates are always x, y. 5, 0. Which makes this guy over here -5, 0. Hasn't gone up and down at all, so its y coordinate is 0, but it is -5 on the x-axis. Go ahead and do your y intercepts. All right. What do these intercepts all have in common? They all have 0s and 5s. Okay? If you walk in any direction, you'll walk 5 kilometers away, and that will be the end of the range. If you happen to be going along one of the axes, then those 5 kilometers that you walk are only involving the vertical, 5, 0, or only the horizontal. By the way, I wrote these wrong. You guys are supposed to catch my mistakes for donuts.
I did.
Don't you understand?
I did. I just didn't say anything.
Well, that's not very helpful, is it? Okay, so this is actually 0, 5, and this is 0, -5. You guys should owe me donuts after something that poor.
Actually?
Okay,
Fine. I'll say something next time.
what are we gonna, let's make a little note here. What do they all have in common? All points are 5 units from the origin. All points are 5 units from the origin. Now, what if you went somewhere else on the circle? Like, let's say here at 4, -3. That point is on the circle. Do you think it also is 5 units away from the origin? Or is it closer?
It's closer.
Or is it farther?
It's exactly
That's same. It's same.
How do you know?
Because it's a circle.
Because it's a circle. What's that word that gets us from the middle of the circle to the edge of the circle?
radius.
The radius. So this is a radius, and this represents the radius, and this represents the radius, and what about this point over here?
Yes.
Radius.
Yeah, that point represents the radius. Okay, at -3, -4. Let's mark that one too. Go ahead and pick another point that the circle goes directly through. How far away do you think that one is?
-4, 1.
Radius.
It definitely does not go through -4, 1. -4, 1 is right here.
Yeah, I thought you were talking about like any point.
Any point that the circle goes through.
Oh, -3, 4.
Yep. Alright, let's see if it actually is 5 units away from the origin. Do we have a formula that tells us the length of a line?
Yes.
Distance formula or length formula. Yep, sounds good. Let's copy it down. You do it from memory and then check up here to see how you did. Because we're talking about coordinate geometry, so we're working with coordinates.
I think my line's wrong.
If you started at the origin and you did a perfect 5-unit circle, then your line will be okay. Go ahead and check your formula with mine, see if you got it correct. If you didn't, shame on you. And pick any of the points that you did. Maybe we'll do it over here. I'm gonna do this point. If you wanna stick with me and copy and do the same, that's okay. I'm gonna call this point A. T is actually gonna be the origin. We're gonna change his name to O for origin. So we're looking at the distance from O to A. And I'm gonna sub in what I know. My x coordinate is 4, so I've got 4 take away 0 in my first bracket. That's going to be squared. Then I'm going to add, my y coordinate is -3. It's going to be -3 take away 0. That's going to be squared. Simplify that out underneath the radical. We've got 4 take away 0, that's 4. 4 squared is?
16.
Then I've got -3 squared.
Is 9.
Positive 9. 16 plus 9 is? And the square root of 25? Did it work?
Yeah.
You think it would work for every other point on that circle?
Yes.
Always, no matter what?
Yes.
What if I wasn't at an exact grid crossing? What if I chose like this point up here? Do you think it would still work?
Yeah.
Yeah, except for our calculations, you'd end up having to round those numbers, which would give you a rounded number. So it doesn't work out as beautifully, but it is always going to be 5 units along that circle. Where does the length formula come from exactly? What formula is it derived from?
Pythagorean.
No,
Not Pythagorean.
Yeah.
it's derived from this formula. Okay, so now you can already start to see the connection between circles, the radius, an equation for a circle, and the Pythagorean theorem. All right, we are going to do the little number 4 there at the bottom of the page. It says, mark a point P anywhere on the circle, construct a right angle triangle with OP as the hypotenuse, and the rise and run as the 2 other sides. I'm just going to use A that I already have here, and I'm going to say OA, which we already calculated, is going to be my hypotenuse. Okay, and now we're going to complete out a right angle triangle. I'm going to go down 3, just like my y coordinate tells me to, and I'm going to go a run of positive 4, just like my x coordinate tells me to. Okay, so here we have the rise, and here we have the run. So the length of OA, is actually, I can plug it right into my distance formula here. It's going to be the square root of the rise squared plus the run squared. Rise squared plus run squared. Why is that true? Well, that's simply true because of the Pythagorean theorem. Because rise squared plus run squared equals OA squared.
It's OP.
Yeah, I'm doing OA. But yes, I understand that this is a P. Okay? There is another way. This is it's going to give us another way to write it that we'll be able to talk about in the next as we flip the page, and then you'll start to see the connection here. Do you need to see that still? Okay. So we drew our figure here. I used OA. They use the letter P. P is a good letter because it's the first letter of the word point. It just means any point. So whenever you see point P, it often means this is a generic point. We don't actually know where it is. They give it the coordinates x, y. So what we're going to do next is we're going to develop an equation for a circle. We're going to do the exact same we just did. We did it with known values. Okay? We're going to do the exact same thing now with unknown values, with x and y as the coordinates. Like they could be anywhere on the circle, and you'll see what happens. Okay? So here's what we have on the top of the next page, part 5. It says write an equation that relates the length of OP to the length of the two other sides of the right triangle. We already did that on the bottom of the last page, so I'm just going to translate it a little bit. But we know that since a squared plus b squared equals c squared, and OP was our hypotenuse, then I've got OP squared equals, and I'm just going to flip my paper over so I can show you, it's going to be the change in x. So my x coordinate is going to get squared, and then my y coordinate is going to get squared. Okay? So that's what's happening here. The rise is your y's, and since you're starting at 0, the y coordinate tells me exactly how far I've moved. And I'm starting from 0, going down -3. Same with the x coordinate. It tells me exactly how far I've moved in the x direction because I'm starting at 0. I'm starting at an x value of 0 and moving to 4. Okay? So that's where we're going to get this next part from. I take the coordinates of P, and I end up with x squared plus y squared. Okay, and I can explain that again very briefly. Here's my right angle triangle. Here's my origin. Here's my point P. Point P has coordinates x, y. The x coordinate tells me exactly how far I've moved in the x direction. And the y coordinate tells me exactly how far I've moved in the y direction because I started at the origin. So all I need to do to get my rise is to take y, and all I need to do to get my run is to take x, and I know that a squared plus b squared equals c squared. Okay, a squared plus b squared equals c squared, where the hypotenuse is always c squared by itself on the other side. Now, what does it tell us to do? It says, since you know the distance of OP, you already did that. The radius of the circle is 5. So why don't we sub 5 for OP and see what we get? Well, what's 5 squared?
25.
25. And I'm going to flip these around just so you can make the final connection here. This right here is the equation of the circle that we drew on the first page with a radius of 5. any combination of x and y that makes this statement true is going to represent a point on the circle. Any point P that has coordinates x, y, where x squared plus y squared equals 25, it's going to be on that circle that had a radius of 5. Okay, does that make sense? Okay, I'm going to demonstrate that just very briefly in another way, right here. So we have this circle, okay? Its center is at the origin. I could draw an infinite number of right angle triangles. Should have maybe drawn my line first and then my dot. I can draw an infinite number of right angle triangles to complete this triangle. If I know that the radius is 5, that means it's going to go through 5, 5, negative 5, negative 5. Okay? I know that whatever point I'm at, this x and this y are going to satisfy this relationship. X squared plus y squared equals 25. It's going to happen every single time, no matter where I draw that dot. Sometimes the value of x will be bigger. Okay, see how it's close to 5, but it's not 5? It's less than 5. And sometimes the value of y will be smaller. Okay? But the relationship, this relationship will always be true. I could draw another triangle. I could draw a triangle way up here. Okay, let's say I'm going to go through that point on the circle. And now this line is my hypotenuse from O to P. Well, now the distance, my x distance, is very small, and it's negative. And my y distance is larger, but this relationship is still going to be true. I could move this point just a little bit over here and draw my right angle triangle. Here's my distance in x. From here to here is my distance in y. And this relationship is still going to be true because my hypotenuse is still going to be 5. A squared plus b squared will equal c squared. And that will satisfy the equation. That gives me this equation for the circle. Any combination of x and y where this is true means that point is on the circle. Okay? If I take a point in here, and I take the x coordinate, and I take the y coordinate, and I plug it in this side of the relationship, do you think I'm going to get a number 25? If I take this point right here, am I going to get 25 out?
No.
No. What number is this going to be? Is it going to be bigger or smaller? Smaller. What about if I take this point over here?
Bigger.
It's going to be bigger. Okay? What if I get this point right here?
It's going to be 25.
It's going to be 25. What if x and y are the exact same value and it equals 25?
It'll be a decimal.
It's going to be on the circle, but x, your change in y and your change in x will be equal. Okay? You can work that all the way around the circle. This will always be true. If it's true, that means the point is on the circle. If the point is on the circle, it means this is true. Okay? Okay, heading back to our worksheet then to finish it up. Number 6 says verify that the points A and B from an earlier section, the ones that you came up with, 2 other points on the circle. So we can just pick any other points that fall on the circle. We'll just do it once. Verify that one of these points satisfy the equation that we made in step 5. So let's take the point A. What was, somebody give me one of the points that they said was on the circle?
4, 3.
Sure, 4, 3. That's positive. They're both positive, so it's a bit too easy, but that's okay. They'll all come out the same no matter what. We're going to verify that it's actually on the circle. So the left side of my equation here is x squared plus y squared. The right side is 25. Do you think it's going to come out as 25?
Yes.
So we've got 4 squared plus 3 squared, just subbing in what we know, x, y. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. That equals my right side. Therefore, A at 4, 3 is on the circle, and it satisfies the equation. Okay? This is good so far? 7. Will the coordinates of every other point on the circle also satisfy the equation? Will the coordinates of every other point on the circle
Yes.
satisfy the... Yes. How many points are there on the circle?
Infinite.
Infinite. Okay? Infinite. Any combination of x, y that makes this true will be on the circle. This is because the hypotenuse of every right-angled triangle that could be made in this way will have a length of...
25.
The hypotenuse will have a length of 5 units. The same length as the radius of the circle. Okay, that's what we spent time drawing out on our whiteboard just a moment ago. All right, here's what he finds out. Trevor finds out that away from the built-up areas, his radios have a range of 7 kilometers.
Go, Trevor.
Write a new equation to represent this circle. Well, here's the basics of the equation of the circle that had a 5-kilometer radius.
Oh, 7 squared.
So you'd be like this, x squared plus y squared equals radius squared. X squared plus y squared equals 7 squared. X squared plus y squared equals 49. That's the equation of the circle with a center at the origin, and it has the intercepts 7, 7, negative 7, negative 7, and anywhere you go away from the origin is going to be 7 kilometers.
Let's go, Trevor.
Okay? Last step, number 9, write an equation for the circle that has its center at 0, 0, has a radius of r. Okay, let's do that part first. We'll stop there. Write an equation for the circle that has its center at the origin and has a radius of r. So if this is what the equation of a circle looks like, you know that the left side is going to be x squared plus y squared. Notice that's an equation of something you can draw on a two-dimensional grid, and it has an x and a y in it. It's because we need to be able to relate our x's to our y's in order to draw anything on a Cartesian plane. Okay, do we know what the radius is? Do we know what the radius is?
Yes.
You can answer that both ways. You don't know the specific value, but you do know that the radius is r. There it is. R squared. That part's done. It says, then use this equation to write an expression for the radius r. So if you wanted to find out how long r is, you would want to rearrange this and express it in terms of r, with r by itself on the one side.
Square.
So I'm going to rewrite this with r squared on the left and x squared plus y squared on the right. And how do I get r by itself? How do I undo squaring something?
You square root.
Square root it. I have to do the inverse operation, okay? Addition and subtraction are inverse. Multiplication and division are inverse. Squaring and square rooting are inverse. If I do it to one side, I have to do it to the other side. Now, squaring a square root or square rooting a square just leaves me with the thing that was underneath the radical to begin with. Just leaves me with r. Left and on the right hand side, we'll copy down what we have. There's an expression for r and the equation of a circle where we don't know the radius. Okay, so now you have the equation of a circle, equation of circle. This is only true with if its origin is at the center. Okay, this is the equation of a circle, and this is expression for the radius. Okay, I've tried to do my best at explaining to you how it works. From this point on, legitimately, all you need to do is memorize this. A squared plus b squared equals c squared. Okay? X squared plus y squared equals r squared. And this. And they're actually the exact same formula, just rearranged. And this really is just your distance formula.
Wouldn't it be r equals x plus y?
Yeah. So it was my question.
Okay, so we have a couple of examples to do. In example 1, we're going to find an equation for the circle that has its center at the origin, at 0, 0, and has a radius of 4. Alright, well, the distance from the origin, and remember, it doesn't matter how bad your drawing is. Look at the words or look at the diagram for things you do know. This is pretty bad, but the distance from any point on the circle to the origin is going to be 4.
This is 5.
Okay, because the radius is 4.
Oh, it is.
So that means I'm going to go through 4, 0. Means I'm going to go through 0, negative 4. Means I'm going to go through 0, positive 4. And it means I'm going to go through negative 4, 0. Those are things I already know about it. We can call this point P. It's got coordinates x, y. Okay, I'm helping you think through it again just like we did before. And I know that the length of OP is 4. So I'm thinking through this and I'm like, oh yeah, here's my right angle triangle. There and there. Okay, what's this distance? Well, this is my x distance, how far I went along my x-axis. And this is my y distance. That's how far I've gone along my y-axis. So what do I know? Well, I know the equation of a circle. I know the equation of a circle is x squared plus y squared equals r squared. And I know that r is 4. So x squared plus y squared equals 4 squared. And I know that 4 squared is 16. So the equation of my circle is x squared plus y squared equals 16. Okay? And again, this comes right from the distance formula, if you want to see it that way. I've got OP equals the square root of x2 minus x1. If you don't need this, don't copy it down, okay? y2 minus y1, that's the change in y. There's my distance formula. Let's look at what happens. Well, I know that the origin is my x1, y1, and I don't know my point. It could be any coordinates at all. So I'm just going to leave x and y in there. Watch this. I've got x minus 0 plus y minus 0 in my formula. X minus 0 is x. Y minus 0 is y. There's a formula for the length OP. Okay? In this case, I know that OP is 4, because that's what it told me in the problem. That has a radius of 4. So now, if I wanted to continue to simplify this, I see that this whole side is squared. Sorry, square rooted. So I'm going to square both sides. On the right hand side, this square is going to eliminate this square root, leaving me with just x squared plus y squared. And on the left, 4 squared is 16.
I'm confused. Why did you square it?
Because in algebra, I can undo an operation by using its inverse operation. So I saw that this whole side, this group right here, x squared plus y squared, was being square rooted. And I know if I take that square rooted thing and I square it, all I'm going to be left with is the thing underneath it.
Smart.
And if I do it to one side, I have to do it to the other side. And that got me the exact same equation as I got using my new formula for a circle.
So that's top one's easier to do?
The top one is all you need to know how to do. This hopefully helps you understand it. Okay? This is simply derived from the length formula. They're the exact same thing, Except up here, you don't have x2 minus x1 and y2 minus y1 because you already know that it's going through 0, 0. You know that the second coordinates in both of these sets is 0, 0. So look at what happened when we simplified it out. When we put in our x and our 0 and our y and our 0, we just came out with the same thing that we have up here. Okay?
You got one.
Okay, example 2. Example 2, we're going to determine whether a point lies inside a circle. So, does it lie inside? How will I know if it lands inside?
If it's smaller than the radius.
If x squared plus y squared is less than the radius. Okay, that's what I'm looking for. Good job. Alright, A says determine an equation and the radius for the circle that has its center at the origin. Center at the origin. And it passes through the point A at 6, negative 8. So I'm just going to go ahead and draw that somewhere down here because that's kind of where it would be. It goes through 6, negative 8. So I know that this point satisfies the equation. And I'm going to develop an equation for the circle that I just drew with only this information. Okay? And I can do it. It goes through the origin, and it has a point on it of 6, negative 8. Well, I know that the equation of a circle is x squared plus y squared equals r squared. And I know a ordered pair, coordinates, x, y, that satisfy the equation. Really important. If you still aren't sure what it means to satisfy the equation, I use that line like probably 6 times a day. So it's time to learn that one, okay? So all I need to do is sub in my value for x and sub in my value for y. And now look, the only thing left is r. And if the radius that I find here is true for this point, what else do I know? It's going to be true all the way around the circle, isn't it? The radius of a circle never changes around the circle. All right, 6 squared is 36. 8 squared is 64. 36 plus 64.
Lots of stuff.
Now I don't need r squared, I need r. I want to know what the radius of this circle is. Although I don't actually really need it, but I will do that anyway. So I need to take the square root of both sides. That's going to leave me with just r on one side. And what's the square root of 100?
10.
10. Okay, Mr. V, what did you do there? You had r squared and now you just have r. I took the square root of this side. If I take the square root of a square, I just get the thing that was underneath. I just get r, which means I have to take the square root of this side. R equals 10. Double check my answer in my head. 10 times 10 is 100. Yep. So this gives me the equation of the circle. Therefore, the equation of the circle is x squared plus y squared equals 10 squared, which is 100. This is the equation of the circle. That means any x and y that is on the circle will satisfy this equation. And now I've got part B. Part B says, is the point, is B at negative 5, 9 in the circle? What's your guess?
I don't think so. Ooh, yes, it would be. Yes.
No.
I don't know.
The circle goes through 6, negative 8. Is this one going to be in the circle, on the circle, or out of the circle? Okay, how do I find out? Well, I just use my situation here. This is going to be a new, it's going to kind of form a new circle, right? I'm basically finding a new radius for a different circle and then seeing if that circle's inside or outside the original circle. So I'm going to call my radius for this one R2, R sub 2, okay, not R squared. R sub 2, it's my second radius. I already have a R1 up here. It's 10. And I know that the radius of any circle the relationship of the radius of any circle, the length of it is the square root of x squared plus y squared. Okay, that comes straight from the work that we've already done in this lesson. Well, I have an x and a y for point B, so I'm going to plug those in. My x coordinate is -5. Put it in brackets. I'm going to square that. And my y coordinate is 9. I'm going to square that. Just a helpful side note, okay? You have to put this in brackets. If you write it like this, -5 squared, okay? This means the square root order of operations, right? You have to do the exponent before the negative sign. So this is actually -25, okay? Whereas this means that the negative belongs to the 5, and I need to do that first, and I'm actually taking -5 times -5, which is +25. You can see how different that is. Exact opposites, not the same at all. 0 points for doing it wrong. I also need to make sure I end up with a positive under the radical. We know that rule already. So we're going to double check that way too. So I have 25 plus 81 underneath this radical. 25 plus 81 gives me what? 106. So my new radius is the square root of 106. My old radius was the square root of 100. So are we inside, on, or outside?
Outside.
Yeah, this is going to be approximately 10.3. Therefore, maybe I should write a little sentence for us. Since R2 is greater than 10, B at -5, 9 is outside the circle x squared plus y squared equals 10. Oh, sorry, equals 100. Equals 10 squared. Yeah? So we've developed equations for circles, and then we've also found the radius of a circle, which gives us the equation of that circle with only 1 point on the whole circle. Okay, you can get the equation of it as long as you know the origin is the center of the circle. And then we could also test whether a point was in, on, or out of the circle just by getting the radius of that second circle that could be formed. And since this radius was bigger, that means it's outside the circle. Your practice problems are listed on the bottom of that sheet. They are in your workbook already. They're from worksheet 2.6. Numbers 1 ACE, 2 ACE, 3 AC, 4 ACE, and 6, 8, 9. All right. Give it your best.